Hi. Today we are going to discuss automated analysis of vulnerabilities in smart contracts. We discussed it with Victor Rabinin for about a year because it's at the juncture of AI, application security, and security of distributed registers. I work in the application security area. Victor deals with security of distributed registers. This is the plan of presentation. There are 4 points: preparation of data, architecture of the solution, how we analyze and chose the features, and the main pipelines. What kind of metrics did we use to evaluate the quality of the solution? We started with data set, with data collection, which took more than half of the time. It's GIGO, garbage in, garbage out. As a result, we had to evaluate the data set manually, very clearly, very thoroughly, correct the sum of the data. 27,000 contracts we got as a result. 79% were vulnerable. Of course, we could write 0 here, but we decided to operate honestly because the language Solidity is mobile, changeable, and the attack vectors change as a result. And we always have to take into account the repository quality, not to use old things, obsolete things. That's why we had a lot of vulnerable contracts. We used oversampling and undersampling when we added synthetically generated classes. Undersampling, when from majority class we eliminate part of the contracts, which reduced the data set and made it synthetic. And we learned some patterns and we didn't find some of the factors. So we used cross-validation when we split the data set. And for example, if we have 10 contracts, we had to have at least 8 vulnerable and 2 non-vulnerable to reduce the number of the majority class. As I said, we checked data relevance because some of the contracts can be obsolete, unapplicable. We took contracts from GitHub. We had student contract, training contract, open source contracts which cannot be used. We eliminated them manually, and false positives were also deleted manually. In Solidity, there were some errors in semantic code analysis. Such tokens prevailed, which were not representative for Solidity as a whole. The main architecture, the main idea was to reduce the number of false positives, and besides, to scale up the solution, which means that we can add new contracts, up-to-date contracts, and retrain the model and use the solution for other programming languages, because we have a hybrid solution. Hybrid approach means that to begin with, we made statistical analysis. of smart contracts. Modifiers, cycles, I will tell you later about the features. We analyzed dangerous constructions and listen main frill patterns of well-known vulnerabilities. Then we generated graphs for our vulnerabilities, syntax, interaction of functions, semantic problems, data flow. Then we used different training algorithms and found non-trivial mistakes to get a better result. So this is a typical map, pair correlation of samples. Of course, we had much more, but I cannot put it on one slide, so I choose only a sample. Part of the, we had 6 main things for solidity contracts and analyzed them. For example, there are some well correlated things. For example, the length of code, the number of lines, well correlated. Solidity means that byte size is also important. But the number of lines can be small. What is bad here? We had to use the data set and the contracts that could split those things to look at the code from different sides, from different viewpoints. Other interesting features means linguistic analysis, transformer, classical ML algorithms, code semantics was also taken into account. We chose 2 features, average number of vectorized codes and fast text. Very close, but taking into account very complex context. After we found those features, we saw how the features behave depending on the depth of interaction. The feature which is red reaches 40% of influence in terms of detecting vulnerable code. The longer is the code, the higher is the probability of vulnerability. But when the number of trees grows, that feature stabilizes at about 30%. The low-level features, the number of delegate calls, it's close to 0. If you want to study solidity and look at vulnerabilities of solidity, that vulnerability, that feature will be described, but it is not relevant because we can deal with it very efficiently. What else? We can say some features cross each other. They get the highest result when they are used in pairs. As I said, we used graph analysis. You can see the graph of a vulnerable contract. We need a check before the run, then the balance of resources. The resources are delivered, and we can have recursive attacks when we withdraw money from the bank account while the account is not refreshed. We use it in ML solutions, and we can interpret such solutions very well. Now, the pipeline. This is the results of research. Give freedom to researchers, and he will continue researching, and researching. This is the state of large language models. Victor is going to tell you more tomorrow. I can tell you that ChatGPT-4 gave the best results here, 66% of positives. It's much better than all other LMs, although even 66% is not enough to use it only. When we audit smart contracts, we cannot eliminate, we cannot use external services like ChatGPT. Within this research, we found Solidity vulnerability tool. It's not the best one because what kind of data set was used to train this LM? We used our own data set and our own hybrid code was used. So it improved our results in terms of interpretability, analysis of input and output data. In output, we had 3 types of graphs: structure of code, execution of code, and links between code parts. All that was called a hybrid input. This is analytics of this graph LLM before we trained it and after we trained it, and the results were down by about 10%, but we took a decision to leave it with not the best result, 0.71, because we can interpret it, because it is focused on our task, because we use the hybrid approach. And when in future we're going to improve it, not just split contracts between vulnerable and non-vulnerable, because we have 27,000 of contracts. We can range the vulnerabilities by their importance, and we can even train our analysis tools to range vulnerabilities. How did we analyze our Solidity contracts? 4 main algorithms: logical regression, boosting, support vector machine, or SV. Why did we use such algorithms? Each algorithm, ML algorithm, is used for a certain task. We have complex data. We didn't know anything about linear developments, linear dependencies, and we use ensemble models. So why not? Logical regression gave us not the best solution, about 0.87, because logical regression sees only linear dependencies. It's very difficult to interpret complex data for it, but it works. The number of lines, the size of code is a representative feature, and logical regression uses it. Besides random forest algorithm, each tree in that forest is used. The precision is about 0.9. Then gradient algorithm is more complex. It works. Each next tree takes into account errors of previous trees. Support vector machines is an algorithm which builds a hyperplane, which helps us split the contracts into vulnerable and non-vulnerable. It gives us something like logical regression, but we use complex dependencies between features. And this algorithm was very good, very strong. Of course, it's heavy. It takes a lot of time to learn, and people loved it, but now it's not as popular as before. I loved it anyway. Then hard voting and soft voting was used. Hard voting, if three algorithms say that it's vulnerable, one says non-vulnerable, we say it's vulnerable. And then
наши модели.
What else? Ensemble and random forest were the most precise algorithms. Next metric which was analyzed is standard deviation. What did we do? We split the sample into batches and saw how precise was. Logical regression and soft voting were quite positive, quite stable, while gradient boosting and random forest gave us less stability in different patches. Precision, well, ensemble models, hard voting and soft voting were good. It's about 0.9. Logical regression was the least precise. How many contracts were vulnerable? We wanted to reduce false positives as much as possible, and that's why this metric was important for us. And logical regression showed us the highest possible number of contracts, because logical regression made a lot of false positives, but for ensemble models, they didn't give us a lot of weight. We applied very small weight to it, and in the complex, they worked together, all of them. After that, how many vulnerable contracts were missed? That is quality evaluation. Logical regression showed us very well because, well, it had a lot of false positive, but it didn't miss any vulnerable contracts. It registered all of them, and ROC-AUC showed us how well the product works, how stable it is. For example, hard work voting didn't give us any probability. It's yes or no. Soft voting gave us good. The top result is zero, is one. What about the consequences? Ensemble of the traditional models showed us the optimal balance of precision and stability. It requires certain tuning because it increases the complexity, increases the precision, and helps us to find rare patterns, vulnerability patterns. This is evaluation of quality, metric by metric. We used several approaches, including ensemble model, post-ensemble model, which gave us 0.91 precision, and we're going to focus on that precision. Graph model was, we tried to use it, but we had worse results. Why? It looks as if graph model can be used without classical ML algorithms. It works rather well. We use IST, semantic of code, data full graph, full graph. What else? What else do we need? Why didn't we get good results? Because the data set is small, 27,000 contracts. We would rather have 270,000 or even more. Interpretation of results is better when we use in parallel graphs and ensemble models. We see the results, we compare them, we check the differences and analyze why the difference occurs. So the complex model is good. ML and Web3 are the technologies which are at the front end, and we want to use them. If you didn't start using ML, do it, please, because it helps you to go deep into solidity. It's mathematics, it's interpreted very well, metric by metric, everything is visual, everything is understandable. We can go to Q&A. Thank you.
Просьба надо к микрофону подходить, мне кажется.
So please use the microphone.
Well,
let me tell you that I will answer the questions about ML, and Andrei will answer questions about solidity. Thank you very much for the presentation. It was very interesting. I have a question. As far as I understand, you used LLM for analysis, but it looks as if smart contract is an important part of a financial system. Why didn't you use non-probability patterns to analyze the contract as an expert system to explain the rules or the latest vulnerabilities found in the analysis system? Well, good question. I can give two answers. First, the hypothesis about LLM and classical ML, both were used. Well, we wanted to have a scalable solution, C++ and a universal principle that can be developed and expanded. Now you say about filling new features, new data, that will make our model more heavy. So we show that it works with solidity very well. Then it was just a test. We lack expertise in solidity. I asked Victor, each feature was discussed a million times, and in future we're going to add features, but today we have what we have. One more small question. Please, how did you mark 27,000 contracts? Good question. We took open data sets with where data set marking was already used. Well, we marked manually by ChatGPT and then checked and rechecked. Of course, that was a difficult process. 27,000, well, well, let me add, we used parsing, and we checked not only how full the information was, but also what kind of uh, time limits were placed for each bug. Some links were links for code reference about the bug. We could go through that to that link and add data to the sample. But the most difficult thing was not the vulnerability sample, but samples of the contracts, which were so-called non-vulnerable, because we didn't have any data sets for such contracts. What did we do? We took top 30 projects of that kind. It was financial contracts. The more money is in the project, the more secure it is. And then top 50, top 60, we found bugs, non-critical ones, but still low and medium criticality. So top 30 projects were the cleanest. Despite that, we found only 5,000 samples. Each contract was split into other subcategories. Solidity is a difficult language because we have few developers and not a lot of good codes. I talked to ChatGPT about data sets, what kind of data set we're going to choose.
Но в итоге как раз у нас в ту сторону код. И есть некоторый страх, что контракт неуязвимый, просто
we had
Спасибо.
we feared that the contract should be non-vulnerable. This is a QR code. You can vote for the presentation, leave the feedback, and after that, out of all the who left the feedback, we are going to have a lottery about books, about Ada Lovelace and Babbage. Thank you for the presentation. I missed the beginning. So, but in classical algorithms, you gave us some metrics. What was the target for training? Was it a binary target? The contract is hypothetically vulnerable, or how did you tune the model? What is the type of the bug, where the bug is? No, we would like to have that. We would like to teach ML to find where the bug is, but at this stage, we can only say vulnerable or non-vulnerable at the binary level. LLM generate tokens, and it's difficult with precision. To add it to the model, it was manual. Well, if I got you right, the model was trained at individual contracts, not at groups of contracts, because usually an application is written not for one contract, but for a set of contracts with library. Yes. Well, because contracts import other contracts. Yes, we used contracts. We had features which take into account availability of imports, but we didn't use groups of contracts because this was only first attempt. This is something for the future. Hi. Good afternoon. One question about the choice of LLM. LLM has limited context, and we suppose that we had more false positives depending on the size of the contracts. The more lines, the more false positives, false negatives. Did you see that? How did you solve that problem? As you see, we have a hybrid input. That's why we believe that we eliminated tokens and contracts were not very long, actually, but the wrong choice of LLM was done. Because solidity graph, we have to use the model, which was not the best one. We had to change it. So maybe one day we'll have a lot of contracts and train the model from scratch. About data sets with vulnerabilities, if we look at data sets from Solidity and consensus, they contain only part of the contract or maximum one contract without other contracts. So the problem, we didn't have any problem with the size of the code. Thank you. Hi, thank you for the presentation. I have a creative question. What about using LLM together with formal verification of smart contracts? It's mainstream. Formal verification is done by other specialists. And no, there is no link. So now you learned the models, we found vulnerabilities, you have trees. Did you think about training the models to formulate theorems which can be analyzed? Yes, we had such an idea, and tomorrow we'll have a separate presentation about it. Yes, we had such a feature of invariants and using invariants for advising and Forge, Hidna. Yes, there is a presentation, but it's out of the framework of this presentation. Please come to that presentation. We didn't have enough time. But in general, that presentation is more detailed. Thank you for the presentation. Did you analyze false positives by finding vulnerabilities there which you didn't include in your presentation? Could LLM find something which you didn't expect to find? Very good question, actually. What is the big positive in different models? Because they have different false positives. Each model has different. 400, 500 in each. We realized why this model reacted this way. We had special analysis of false positives and false negatives. We analyzed them, we trained the model. It's an interactive process. Features, we have been doing it for about a year. That's very interesting. For example, did we find anything that we didn't expect? That's interesting. Please write to me and I'll tell you much more about false positives and negatives. Thank you. Did you try any pre-training of the Solidity code to raise the precision? What can you add to make the model more precise? Graphs, comments, anything. Actually, I wouldn't use comments because comments reduced the results, made them worse. LLM doesn't understand your comments. It takes it as a token and starts analyzing it. For LLM, I can tell you, we eliminated the words which exist in all the contracts. We reduced tokenization. We tried graphs, which also helped to analyze the code. 3 types of graphs, which accumulated all the features of Solidity. So it's good to have graphs. If Vladimir uses to do it for Python. If you want to automate and doesn't know what to do, generate graphs and put them into LLMs, learn and analyze the results. Thank you.
Добрый день, меня зовут Виталий. Большое
Hi,
спасибо.
I am Vitaly. Thank you for your presentation. And the question is like this. You've got non-balanced classes, and you had to do the resampling. No, we eliminated that. Oversampling, cross-validation, it was done in the minority class. Undersampling and oversampling didn't work. You can get good results only for your tests, and then later you will not be able to replicate them. Then let me put it differently. Did you try artificially to regenerate objects of the necessary class, the way it is often done when we analyze images? If we have an image of a cat, we can scale it, move it, and semantically it will still be a cat. Can we use such an approach to smart contracts, to codes? Take two good contracts and artificially build the third contract, which will be non-vulnerable. It's not about oversampling and undersampling. It's different. Oversampling, undersampling, no. About your third approach, no. We filtered away data. We tried to eliminate similar contract so that we wouldn't have any overestimation of a certain type of contracts. If we have contracts which are quite similar, we don't have to train the model on these two contracts. If it doesn't have a feature, a vulnerability, it wouldn't be there. If it has a vulnerability, if you replicate the contract, you will have more and more and more of those vulnerabilities. So we tried to make all our contracts to be different. It's very dangerous to use similar contracts. We have 9 types of basic vulnerabilities for smart contracts. But what was the data set which was used to generate those 9? Well, it was a synthetic data set which was generated the way you said, and actually it was just one token, and a lot of contracts were generated, but they were similar. 100% of vulnerabilities were detected, but it was only one contract. If you focus on something narrow, well, it will be bad. So you have to have diversity, then only it will be precise. We try to refresh, update, use new constructs, new types of transactions. If we take all types of vulnerabilities, we also filtered them for version 4, version 8. Sometimes we eliminate them if they are closed, solved, they don't influence us any longer. They don't influence us now because they are known. It's one of the approaches to check actuality of the data set. We checked import safe mass. It's old, it's obsolete. it doesn't, we don't have any new contracts with such features. So good, so eliminate it.
Спасибо большое.
Thank you very much. Thank you.
Теперь нужно выбрать победителя.
Now we have to choose the best question. There is one more question. Thank you. Thank you. As the previous speaker said, there are formal verification methods, symbol verification methods, and you offer machine learning for smartphone, smart contracts. What are the benefits of your method, taking into account that you use formal verification as well?
Формальной верификацией в данном исследовании мы не занимались, а
Formal verification was not used in this research. What are the benefits?
инструмент, который будет
It can be included in a certain tool that is going to check the smart contract that you deploy, that you generate, and show you the probability of errors. There was a good question about false positives and false negatives. Yes, we analyze them and we generate new patterns, which is important.
Как вы сказали, что
As you said,
ваше решение может выдавать
in general, your solution can produce false positives and negatives. It's a mathematical model. The number of falses, the number of errors should be minimal. Accordingly, from the point of view of a developer, how a developer should understand that by using your ML models, they can work in the right way, that this is really false and not false positive.
формальная верификация это довольно трудоемкий процесс.
Formal verification, it takes a lot of time and effort. This solution
Оперативного
is more for
исследования смарт-контракта,
quick
отображения ситуации и
scanning of smart contracts. We can just pay attention of the developer to a certain piece of code and say that probably it contains an error. This is what I see in this solution. Maybe I am wrong. For education, if you learn Solidity, you can check yourself, you can check your own work quickly. Thank you.
Здравствуйте, спасибо за доклад.
Hi.
Можете, пожалуйста,
Thank you.
с реэнтранси, где вы показывали?
What about your slide with reentrancy? I wanted to see it's the last line will cause the underflow. You say that you tested vulnerabilities in Solidity. It's data set checking. It was done in October, November to demonstrate visualization. Maybe Victor can comment. It's about reentrancy. I can give you the full code. If you put 0 in the last line, it will be okay. Otherwise, it's an underflow. Oh, yes. Yes, it will be an error. Right, you are. Let me add, if somebody makes an audit, come to me. I have a group of 20 persons who discuss such things. Come to me.